Hello guys, welcome back to the channel Mathemagix JEE. So this is the question number 5. It is saying let f defined from open minus 1 to 1 to r be a function defined by f of alpha like this. Okay. So f of alpha is defined in terms of this integral where alpha is a variable parameter. So we need to first calculate this f x. Okay. F of alpha we can say. So let us first calculate this f of alpha. So if we simplify this integral, it is d theta divided by 1 minus alpha cos theta. Okay. Now this function inside this integral is an even function, right? Because cos theta is even. So we can write this integral as 2 times integral 0 to pi d theta divided by 1 minus alpha cos theta. Now how to further proceed? We have to apply King's rule. Okay. So King's rule says that integral a to b f x dx is same as integral a to b f of a plus b minus x dx. So we can say f of alpha, we can again write by the King's rule that it is equal to integral 0 to pi d theta divided by 1 minus alpha into minus cos theta, that is plus alpha cos theta. Okay, because cos of pi minus theta is minus cos theta. Now if we add this to f of alpha here, so f of alpha plus f of alpha will give us 2 outside and then integral sign, then it will be 1 divided by 1 minus alpha cos theta plus 1 divided by 1 plus alpha cos theta times d theta. Okay, so like this. So if we simplify this, we get integral 0 to pi, then 1 minus alpha square cos square theta d theta, then in the numerator we get 2, right? So 4 times integral 0 to pi, then d theta divided by 1 minus alpha square cos square theta. Now how to calculate this integral? This is a very standard integral. Okay, whenever we see even powers of cos or sine in the denominator, we generally divide by sine square theta or cos square theta depending on the situation. So for example, here it is cos square theta, so we divide by sine square theta to create a cot square theta here and cosecant square theta here, and also a cosecant square theta in the numerator. So whenever we put cot theta equal to t, we will get minus cosec square theta d theta as our dt, right? So before performing or solving this integral, we can further reduce these limits, right? Because here we can see, if we consider this as f of theta, then f of pi minus theta is exactly same as f of theta. That's why we can reduce these limits to half of its original values and then multiply by 2 outside. So 4 times 2, then it will be integral 0 to pi by 2, then d theta divided by 1 minus alpha square cos square theta, right? Now if we see here, we can cancel this 2 here because we are to calculate f of alpha, not 2 f of alpha, right? So f of alpha is this integral 4 times integral 0 to pi by 2 d theta divided by this. Now if we want to solve this integral, we have to divide by sine square theta, that means cosecant square theta d theta divided by this, we can write as cosecant square theta minus alpha square cot square theta. Now if we solve this integral patiently, so 4, then integral 0 to pi by 2, it is cosecant square theta d theta divided by this is cosecant square theta, so we want to convert this into in terms of cot theta, right? Because we don't want distinct terms here, so we want 1 plus cot square theta, which we can write as 1 plus 1 minus alpha square times cot square theta. So now if we, let's say, choose this as our t square, okay, so t we put root under 1 minus alpha square then cot theta, okay, then we will get dt as root under 1 minus alpha square times minus cosec square theta d theta. So we will get 4 times integral, this will be minus dt divided by 1 plus t square, and also there will be a factor of root under 1 minus alpha square. Okay. Now what will be the limits? If we tend theta towards 0, t will tend toward infinity. And when theta is pi by 2, we get t is equal to 0. So we get from here 4 divided by 1 minus alpha square under root times this will be nothing but integral 0 to infinity dt divided by 1 plus t square. Now this integral we all know this is standard, so it is equal to tan inverse infinity minus 0, right? So tan inverse infinity is pi by 2, so we get our answer as 2 pi divided by root under 1 minus alpha square. So f of alpha is this. Now let us jump to the options. Okay, now we verify these options one by one. So let us first calculate this a and d option first. Check these two options because these are simple integrals of this function. So we know f of x is what? 2 pi divided by root under 1 minus x square. So if we calculate this integral 1 by 2 to 1 by root 2 integral f of dx, we get this is equal to 2 pi sine inverse x, right, with limits from 1 by root 2 to half. So it comes out to be 2 pi into pi by 4 minus pi by 6. So if you calculate this, it will be pi square divided by 6. Okay, so this is clearly not correct. So option A is not correct. Okay, now option D, if we check integral 0 to half fx dx, it is equal to 2 pi sine inverse x with limits half and 0. So it will be 2 pi into pi divided by 6, right? So pi square divided by 3. So option D will be one of the correct options, right? Now let us check option B and C. B is saying if alpha is root 3 by 2, then tan of f alpha is 0. Okay. So if we have alpha equal to root 3 by 2, right? So f of alpha is 2 pi divided by under root 1 minus alpha square. So 1 minus 3 by 4 is 1 by 4, and under root of this will give us half. So it will be 4 pi, right? So tan of 4 pi is 0 because we know tan of any integral multiples of pi is always 0. So this option is again correct. So from here B option is correct. C option is saying there does not exist any alpha belonging to open minus 1 to 1 such that beta such that cos inverse beta equal to f of alpha is not equal to 5. Now this option may seem a little bit of confusing. Okay, so let us decode this. It is saying there does not exist any alpha such that this set is not a null set. So that means there does not exist some alpha such that this equation has a solution. Okay, so let us check this equation first. So cos inverse beta is f of alpha. Okay, now let us check the range of these two sides. Okay, so cos inverse beta, we know already the principal value of the trigonometric functions. Cos inverse beta lies between closed 0 to closed pi, right? And this RHS of this equation has the range closed 2 pi to open infinity, right? Because f of alpha, we already discussed, it is 2 pi divided by under root 1 minus alpha square. For alpha belonging to what? For alpha belonging to this minus 1 to 1 open, right? So we can see if alpha is belonging to this interval, alpha square will be belonging to 0 to 1 open, right? Or it should be closed at 0 because alpha square will be 0 for some value which is alpha equal to 0, right? And alpha equal to 0 falls in this range. So we can say this f of alpha will range from 2 pi when alpha square is 0, and then it will tend towards infinity when alpha square tends to 1. Okay, so we have the LHS range as close 0 to pi and the RHS range as close to pi to open infinity. So we can clearly say that this equation cannot have any solution, right? Because the ranges are different. If sides are to be same, then we have to have some intersection of their ranges, right? So there is no such beta. So beta belongs to 5, right? So we can say there does not exist any alpha such that this equation has a solution. So this option is also true. So option B, option C, and option D will be the correct options for this question.